Okay, I'm told I can start now. So, hey everybody, how's it going today? So, my name's Dan Illson. I work here at VMware. I'm one of our cloud advocates. So, my group is responsible for kind of looking at how our customers are using and interacting with public cloud infrastructure. And we work in a little different way. A lot of the company kind of works through the infrastructure layers up. Our group tends to work through the application layers of a problem down into the infrastructure. So we're a little bit different, and today I'm here to do a brief talk on deploying Kubernetes clusters into Amazon through EKS. So this was actually originally built and developed by my boss, who's not with us this week here, so I'm doing the talk in his stead this week. So my boss, Bill Shetty, put this together originally, but I'll be doing it this afternoon. So our team, we run and maintain our own site with a bunch of content and blogs and some code and other things that we put together. That's us, and then our Twitter account for our team is there. So if you like what you hear over the next few minutes and you're looking for more of similar stuff, that'd be a good place to go and look. So obviously, if you guys are here this week, Kubernetes is kind of a big push for the company these days in terms of how we're thinking about infrastructure and kind of modern applications and container platforms moving forward. Like it or not, right now, the most of the Kubernetes clusters in the world right now are deployed on Amazon's infrastructure somewhere. Whether those are managed clusters that customers are deploying with something like EKS, or they're self-managed clusters getting deployed on top of EC2, EBS, and other baseline Amazon services by customers, region by region and availability zone by availability zone. So for our customers that are working with these, this kind of break down into two problems: your day zero or provisioning and deployment of the cluster problems, and then your so-called day two problems, right? How do you actually make sure that these clusters are alive, responding, generally healthy, appropriately resourced, et cetera, as you move on beyond initial deployment, right? So setting up the clusters are interesting, and we'll go through some of the mechanics there. Although EKS is a fairly nice abstraction for running clusters, it's not the most straightforward to get started with in terms of actually building and getting access to clusters, and we'll look at a bit of that as we go through. And then kind of managing the cluster and making sure it's, again, healthy, available, appropriately resourced, all of those things. And we'll look at some of the connections for that as well. So we will actually look at a cluster I've already got deployed, and we'll actually kick off the deploy of another one here today. So I don't know if this cartoon makes as much sense in Europe as it does in the US. A lot of us in the US grew up with this, but I don't know if it made it to all the different countries in Europe, but a little pinky in the brain. This, though, becomes like life for some administrators right now. It's like, okay, we need another cluster, so what do we do? Several hours worth of work and a bunch of repeating the same steps over and over again, which in our world, every time I see something like that, I say, okay, let's automate this so I don't have to do it anymore, because that seems silly and kind of unnecessary to me. So how do we move through that process? Now, because we're here at a VMware event, the answer that we will provide in terms of how to do this long term generally looks like Tanzu Mission Control, which you heard a lot about in the keynotes the last couple days. Obviously, that's going to be a big push in terms of how we think about and manage the overall life cycle of Kubernetes clusters wherever they happen to be. Amazon, Microsoft, on-premises, et cetera, right? That's how we're going to look at it. Now, this deck was built before there was a Tanzu Mission Control, back when it was still a project code name a few months ago. So the things that we're going to look at are a little bit different, but in the long run, this is how we'll look at it and how we'll think about it. It will be our answer as VMware to the process of managing that life cycle. Okay, so if I want to go and build a cluster on Amazon today, it's actually not as straightforward as I would like it to be, because then I have to go and I have to provision all of this stuff in Amazon individually as components to tie together. which is a non-trivial thing, and I have to manage Amazon's IAM, provision groups of users, give them permission to access the cluster. It's a non-trivial thing, and it does take quite some time. I mean, Amazon provides some nice resources at the links at the bottom now because people have had a harder time with it over the last year or two, but it's still not a trivial process to manage with CloudFormation. So if you wanted to do this, you would build a stack, deploy it yourself. You could do it with raw API calls as well, but that's yet even more complicated. Or the folks at Weaveworks put together a nice little utility to interface with EKS. So the EKSCTL package actually does not come from Amazon at all. It comes from Weaveworks. And they've essentially enabled behavior that will allow you to build an EKS cluster off of a single command, right? So like down here at the bottom, give it a name, give it a region. As long as your user logged in on your machine has access key, secret access key to a valid Amazon identity, it will provision, what you generally asked for against that identity. And if that's something that any of you are interested in looking at, everything to do with that is available here on their GitHub page. So I think you can go to, I believe it's EKSCTL.io. I lost it. It's in here somewhere that you can link to, or it's on their GitHub page. It's off of Weaveworks' GitHub page, all the stuff about this utility. So again, if that's something you're looking for, either GitHub or EKSCTL.io. So, yes, sir. EKSCTL is a project by the company Weaveworks. It's not Amazon originated. So sorry. Yeah, that's a Weaveworks open source project that they put out on GitHub, essentially because Amazon's tools for provisioning EKS clusters were not so nice. And that's actually like how the cluster we'll look at in a moment. That's actually how my boss originally built and provisioned it, was through EKSCTL. Okay, so if you do EKSCTL, essentially what happens is it either takes a default, or if you want to modify it, it essentially builds a YAML description of the cluster that it then goes and provisions through the Amazon API by building a CloudFormation stack and deploying it against Amazon. So what Bill's done here is he's actually put in a bit of the basic config here. If you want, you can turn on SSH to allow you to SSH into the individual nodes of the cluster, things like that. But as you'll see, look, they build a name out for all of the node groups. In this case, they're getting billed off of M5 extra large EC2 instances. You can see the desired capacity too. You can see the basic sketch of the resources you're asking Amazon to provision so that you can put the cluster together. Okay? And if we come here, you can actually see. So you can actually see our cluster. So our cluster is called EKS, Acme Fitness EKS 00. So if you look, there's actually two node groups, node group 1 and node group 2, and they each have two nodes in them, right? And these are our instances that actually make up that cluster. And if we go into EKS, if we go into the EKS service here, we can actually see that provision that way. And where did I go? And this is actually a live account, so this is lots of fun, right? And there's that cluster. Right, so if we look at it and we scroll down through here, you'd see some of the same node groups and everything else going on. Same role ARN and certificate and everything else. So that's what we're actually using. Our provisioning, by the way, looks like that, right? So if I wanted to build another cluster today, I could do this. and it would actually kick off a build of a brand new cluster back in the US, right? And if you look at what's going on here, it's building out subnets, and it's building out, enabling CloudWatch logging, all the normal stuff you would expect for an EKS instance, and then it's building out the stack, the CloudFormation stack that it'll then use to deploy all the individual resources and tie it back to EKS itself. But we'll leave that alone for now. So if I build one of those tools, then how do I, let's say I built out a cluster, right? I built out 10 clusters, doesn't really matter. I built out some arbitrary number. But now I have to administer these things, right? I have to run them, I have to keep them relatively alive and in good state, right? So how do I look at that? Well, a couple things that I'll care about, right? I'll care about what these clusters cost me. I'll care about getting monitoring and logging information out of them and the applications running on them. And I'm probably going to care because they're, in theory, running some application or applications that I care about. I'm going to care about the overall security posture of those clusters, right? So there are Amazon native tools up there like Cost Explorer and CloudTrail and Secrets Manager and things that I could use to do all this myself. But unless I'm running exclusively in Amazon, that may not necessarily fit how I want to operate an environment. So there's other ecosystem tools I could use, right? And then of course, because I work here, there's a selection of tools that we as VMware offer that I tend to prefer, right? So look at Cloud Health for cost utilization, Wavefront for performance and monitoring, and then a newer product called SecureState to kind of look at my security configuration data. Okay? So Cloud Health lets me look at my costing data from my Amazon bill, but then also I can look at utilization data in Cloud Health. So Cloud Health actually, like a lot of products these days, it's capable of installing an aggregator or collector node into the Kubernetes cluster itself to get statistics and usage information about what the cluster itself is running and has provisioned against it. It talks to the API server and gets all those stats and information and can export them out to Cloud Health. So, and we can actually, rather than looking at these screenshots, we can actually pop over. So this is actually my cost model for the last month for that cluster that we were looking at in the Amazon console before. And on this view, it's actually broken up into the different Amazon services that we look at, right? So that's actually my cost to run EKS. That's the cost for my compute nodes. That's the cost for the Redshift that's running against the cluster, and so on and so forth up through all the different pieces that I need to actually run an EKS cluster. It's also a nice way to actually look at some level, all of the resources that opaque CloudFormation stack deployed for us. So that's good. Now we know what's in there. We can also come down, if we don't want to look at cost, we can come down through some of the Kubernetes resources view because we have that aggregator and collector pod running inside the cluster. And we can see, for example, this is just a graph of CPU availability versus consumption. And I could look at any one of a group of different variables and different resources that I can consume from here. So that's one view. Mostly you're going to use it. Mostly people would use this for costing data, but you can also get some usage data as well. Oh. So probably the most interesting for actually running and monitoring the cluster day by day and looking at what's going on in there is looking at the metrics, the cluster and application metrics that you can provide to Wavefront, right? So Wavefront works in a slightly different model in terms of how it gets its data. We actually deploy a Wavefront proxy into the Kubernetes cluster. We give it the correct credentials to talk to the API server of the Kubernetes cluster, and then we configure individual application pods to forward their metrics data through that proxy as well, so that everything comes out in a cluster in a cluster correlated view of overall metrics. So this is the top of the Kubernetes Dashboard in Wavefront. And again, we can actually jump back across, and this is the live running version of that dashboard, right? So just like we saw before, our cluster has 4 nodes. We've got all these basic stats on top. But as we scroll down, we can see that we're also getting namespace-specific data, node-specific data about the individual EC2 instances that are running as our nodes here, down through file system and even the very, very chatty and interesting individual pod data. So this is the default Kubernetes dashboard. And if you look, our team has, I don't know, at any given time, a dozen or so different clusters that we're using across different cloud providers that we aggregate through here. And like, for example, that's an AKS cluster in Azure that we use for a big CI/CD demo that we do as well. So we have a bunch of these things. We look at all our stats aggregated up through Wavefront, and that's kind of how we determine health and what our needs are going to be around capacity and other things that we look at on an ongoing basis. The nice part is, and I don't know if I have one configured for this particular cluster, these are the out-of-the-box dashboards, which actually Wavefront does a really nice job with. You can build as simple or as complicated custom dashboards as you want. So we have custom dashboards, for example, that have some degree of cluster level stats and then application specific stats all kind of running on one dashboard, so we can get the overall health of an environment in a very quick, digestible, easy to consume way. So great service there that we look at. And then the last kind of the security configuration component we look at through a tool called SecureState. So I don't know if SecureState's a product that you're familiar yet. I know we've talked about it a little bit, but it hasn't quite gotten some of the main stage treatment yet. What SecureState is think of SecureState as a giant graph database of cloud configuration data. So when working against a public cloud, you have all this data that comes back from API structures that's all indexed and references each other. So you'll have an internet gateway in Amazon that references a VPC, that references a subnet, that references, and that subnet may have 4 or 5 or 10 instances attached to it, and they all have security groups and roles and all these other constructs that are attached to them at the API level. This product interrogates the cloud provider APIs and builds a giant interconnected graph database of all that information, which is extremely useful because it's easy to check one object for configuration and say, okay, this matches what we think this object should be. It's more difficult to look at an arbitrary environment, a whole VPC, a whole cloud region, and say, hey, do we feel comfortable with our configuration and our security posture across this set of objects that might consist of 6, 8, 10, 12 different object types, each with their own configuration and their own relationships. So the picture here actually shows a partial view of that graph, and what it's seen is a violation in one of our accounts of an instance that is publicly accessible that isn't supposed to be, right? So it's essentially an instance that is on a private subnet, but has access to an internet gateway through a series of other objects. Not an uncommon configuration in the public cloud, but certainly not what was intended, right? So that's why we want to be able to track that. It's a really nice tool. They've done a lot of work with it lately. So it supports NIST and CIS benchmarks out of the box, and they've added support for custom rule sets and a bunch of other things to it in the last couple months since VMworld US. So it's a really nice product, really powerful in terms of the amount of information it can bring in an index. So very valuable, not just for Kubernetes clusters or EKS clusters, but also for any other objects and workloads you may be running across. Today, Amazon or Azure, they're adding Google support in the next few months sometime. So they'll continue to build out that product to support more and more environments. All right. So the Cloud Health Collector we talked about a little bit previously on some of the tools. like everything else in Kubernetes, this is a YAML manifest that we deploy down. You can deploy it manually yourself, or the Cloud Health product has a trigger where you can kind of download the file and inject it into the cluster that way. It's up to you. Either way, it is a pod that runs with a service account and has access to the API server to get stats. It's relatively benign, but if you want to tweak and modify the configuration, you can see the service account and the service account role binding that will be in there, and you can modify them to fit your permission scheme. If you do that, of course, and you make it too restrictive, you may not get as much information as you expect. Similarly, the Wavefront Collector, again, this is all Kubernetes, lots of YAML manifests. The only thing with the Wavefront one is you can either take the generated version from the Wavefront console, or you can build your own, but you'll have to inject your Wavefront API URL and API token so that all the metrics you're sending get properly indexed and displayed against your tenant. Okay. So basically, a few things out of this. So we as a company are not scared of Kubernetes clusters that get deployed via other mechanisms that aren't necessarily VMware branded. You're going to have some of those that they're going to exist in the world. We have to be prepared to deal with them. In the long run, our hope is that our customer base will see value in attaching those clusters to something like Tanzu Mission Control for long-term lifecycle. But if you're going to use EKS, I highly recommend you go check out EKSCTL, because the Amazon methodology to deploy EKS clusters is, I don't think, particularly user-friendly. And then to keep those clusters alive and healthy over the long term, VMware, we offer what we think are really strong tools for cost, performance management, and then security configuration management of those. So please go to check those out, and if you want any more information, cloud.vmware.com has information on all of the VMware products that are part of that, and we'll have information on Tanzu Mission Control as it enters beta and goes GA. Okay? Thanks very much, everybody. Thanks for coming out today. I hope you enjoy the rest of the conference.